Moving on in chapter 2, we're now at section 4, measures of variation. So this is the spread. How far spread apart is your information? One of the easiest ways to look at this is what we call the range. The range is the difference between the maximum and the minimum data entry. 2 corporations hired 10 graduates. The starting salaries for each graduate is shown. Find the range of the starting salaries for Corporation A. So here is Corporation A. The range then is the maximum minus the minimum, the difference. Maximum minus the minimum. So the maximum number in this case looks to be 47. And the minimum looks to be 37. So my range is equal to 47 minus 37, which is equal to 10. In this case, because it's in thousands, the range is $10,000. All right, you try it by finding the salaries for the Corporation B. That will be your next one. All right. Then we do talk more about variation as a whole. So both data sets in the last example have the same mean, and you'll find that out when you do that, the same median and the same mode. And yet the 2 sets differ significantly. So if we look at the 2, they differ significantly. The difference is that the entries in the second set have a greater variation. So a greater range, and you'll see that as well when you do the range. It's a greater range. The starting salaries for Corporation B are more spread out than for those of Corporation A. So again, the spread from the least to the most is much more spread out, where here they're closer in, they're tighter together. Okay. So what does this tell you? We have to be careful if all we're going to do is the mean, median, and the mode. Mean, median, and mode do not tell the whole story. That's why variation becomes very important. All right. The next one is deviation. It's the difference, again, difference meaning subtract, between the data entry X and the mean of the data set. So the population data set would be the X value is equal to X minus the mu, or X minus X bar if we're looking at the sample data. So it's the difference between the entry and the mean this time. We also talk about variance and standard deviation. Standard deviation is going to be the thing that we're going to see the most from now until the end of this chapter. Standard deviation shows up over and over again on how we do things. It's a very popular use in statistics. And we do talk about the difference between population and sample. And so you'll see those differences as well. Your population variance, this is your formula. Your standard deviation basically just says to take the square root of the variance. So your standard deviation is equal to the square root of your variance. All right. Lucky for us, we are going to be able to do a lot of this on our calculator. I'm going to show it to you by hand first a couple of times, then I'll show you how to use your calculator. All right. So, finding the population variance and standard deviation. All right. The population variance and standard deviation for the starting salaries of Corporation A were listed in that first example. So we're going to start out with a chart. I have my salary, which is going to be my X value. I'm going to have to do next my deviation. Not standard deviation, but deviation, which is X minus my mean. And in this case, it was just a sample, so X minus X bar. And then I'm going to need X minus my X Oh, they do want us to use this as a population. So let me go back. I guess that we're using population because it's the entire company's starting salary. We're going to take that, we're going to square it. Okay. And remember that we found the mean. They told us that the mean was equal to 41.5. So that was told to us back here where it talks about the mean being 41.5. So my salary then, I had 41,000, I had 38,000, I had 39,000, I had 45,000, 47,000, 41,000, 44,000, 41,000, 37,000, and 42,000. That's what was given to us. So now we're going to do the deviation, x minus my 41.5. So 41 minus 41.5, 38 minus 41.5, 39 minus 41.5, 45 minus 41.5, 47 minus 41.5, 41 minus 41.5, 44 minus 41.5, 41 minus 41.5, 37 minus 41.5, and 42 minus 41.5. Now, that's going to equal, and the value that it's going to equal is going to be what I want to square. So 41 minus 41.5 is negative 0.5 squared. If I use my calculator, that's like negative 0.5 times negative 0.5, which is equal to positive 0.25. You will find that the whole reason that we square this is so that we end up with positive values, because a negative squared and a positive value squared always gives me positive numbers. So this last column right here is always positive because we're squaring it. Right? So now if I have 38 minus 41.5, that would be negative 3.5 squared. Again, using your calculator. And if you haven't seen where that button is on your calculator, so we would have 38 minus 41.5 equals negative 3.5. And so if I want to do negative 3.5 squared, make sure you use parentheses, negative 3.5, and then the squared button is right there, x squared above the log key, and hit enter, and indeed it is positive 12.25. Make sure you're using parentheses when you square that negative 3.5. It is in parentheses. If you do not use parentheses, you will not get the right answer. So be sure that you're using the parentheses correctly. So this equals 12.25. 39 minus 41.5 is negative 2.5. When I square that, I get 6.25. Again, use your calculator. 45 minus 41.5 is positive 3.5. Well, if negative 3.5 squared is 12.25, then positive is also going to be 12.25. 47 minus 41.5 is 5.5 squared. Again, if you use your calculator, that would be 30.25. 41 minus 41.5 is the same as it was above, negative 0.5 squared, which is 0.25. 44 minus 41.5 41.5 is 2.5 squared. Well, just like negative 2.5 was equal to 6.25, positive 2.5 squared is going to be 6.25. Again, another 41 minus, so that's going to be negative 0.5 squared, which is still equal to 0.25. 37 minus 41.5 is negative 4.5. When I square that, I end up with 20.25. And then the last one, 42 minus 41.5 is positive 0.5 squared, which is still a positive 0.25. So remember, every one of these values now at this point has to be positive. They're always positive. If you do not get a positive value after squaring a number, if you do not get a positive value, you've used your calculator wrong. And more than likely, it's because you didn't use parentheses. All right? So, if I look back at my formulas, my formula says, actually, let me erase this. All right? So my formula says that the variance is equal to the sum of all of these numbers squared divided by n. And then again, the standard deviation is the square root of the variance. Standard deviation is the square root of the variance. So to find my variance, I need to take and sum this last column. This is going to be the sum of x minus mu squared. If I sum that up, 0.25, 12.25, 6.25, and so on, I end up with 88.5. Again, use your calculator to do this. And when you're showing work, this is the kind of work I need to see. I don't need to see what you added on your calculator, but I do need to see that the sum was equal to 88.5. All right, so the variance is going to be the 88.5 divided by n. How many entries do I have here? Well, I end up with 10 salaries. And so that's going to divide by 10. So my variance is equal to 8.85. And then my standard deviation is the square root of the variance. So again, on my calculator, the square root of 8.85, it's not going to be a whole number, it is going to be approximate. So in case you don't know where the square button is on your calculator, square root button is going to be above the squared button. It's kind of hard to see on my example, but it's above the square key. So I'm going to have to hit second to get above it. And there's what square root looks like. Second square root of 8.89. So second square root of 8.85. Hit enter, and that's approximately 2.9748. Approximately 2.9748. Depending on what it tells you to round to, the standard deviation is approximately 2.97. So here's my variance, and here's my standard deviation. It's not hard, it's just a lot of math to do, so you just have to take it a step at a time. All right? So I want you to try it for the salaries for Corporation B, so we can see how much they deviate, how far they deviate from different things. the deviation. All right. Then we're going to look at sample variance and sample standard deviation. It's exactly the same formula for both. Notice we use S instead of sigma, and we use a small s for standard deviation. Truthfully, I'm going to use standard deviation as SD all the time. I know it's not really a good habit to get into, but we're talking standard deviation. Right? And the only difference then is we're going to subtract 1 from the denominator. So instead of 30, it'll be 30 minus 1. Or instead of 10, it'll be 10 minus 1. Right? In a study of high school football players that suffered concussions, researchers placed the players in 2 groups. Players that recovered from their concussions in 14 days or less were placed in group 1. Those that took more than 14 days were placed in group 2. The recovery time for group 1 is listed below. Find the sample, variance, and standard deviation. Find the sample. It's a sample because remember they put some people in group 2, so it's not everybody, it's just some of them. Okay. So we're going to do very much like we did before. We still need the days that it took to recover. We need the deviation, which in this case is going to be x minus x bar, since it's a sample. We're going to need that x minus x bar squared to help us find the variance. So we had 4 days, 7 days, 6, 7, 9, 5, 8, 10, 9, and 8. And there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 students. So this is 10 students or student athletes. All right. So this time I do not know what the mean is. So I do not know what x bar is equal to. So I am going to have to find x bar. How do I find x bar? Well, I'm going to sum up this column. So let me erase this and move it. I'm going to sum up this column. So the sum for the number of days, if I sum this up, 4 plus 7 plus 6 plus 7 plus 9 plus 5 plus 8 plus 10 plus 9 plus 8. If I sum that up, I get 73. Remember that this is 10 football players. So my x bar is going to be 73 divided by 10, which is 7.3. So the average number of days is 7.3. Okay. So again, for the deviation, 4 minus 7.3, 7 minus 7.3, 6 minus 7.3, 7 minus 7.3, 9 minus 7.3, 5 minus 7.3, 8 minus 7.3, 10 minus 7.3, 9 minus 7.3, and 8 minus 7.3. All right, carefully use your calculator. 4 minus 7.3 is a negative 3.3 squared. Remember that these always have to be positive, and that would give me 10.89. 7 minus 7.3 is negative 0.3 squared, which is 0.09. 6 minus 7.3 is negative 1.3 squared, and that's equal 1.69. 7 minus 7.3 is 0.3 squared, just like it was, negative 0.3 squared, which is just like it was 2 problems above, 0.09. 9 minus 7.3 is positive 1.7 squared, which is equal to 2.89. 5 minus 7.3 is negative 2.3 squared, which is 5.29. 8 minus 7.3 is 0.7 squared, which is 0.49. 10 minus 7.3 is 2.7 squared, which is equal to 7.29. 9 minus 7.3 is 1.7 squared, which is 2.89. And 8 minus 7.3 is 0.7, and that squared is equal to 0.49. Right? I have already done this on the side using my calculator, so that's why I'm able to go through it so quickly. But just to remember, we'll do this last entry. So the last entry was 8 minus 7.3, which was equal to 0.7, and 0.7 squared is equal to 0.49. Notice if this was negative 0.7 squared without parentheses, no parentheses on the negative, and look at what my value is, negative 0.49. So again, your negative values have to be in parentheses. So negative 0.7 squared in parentheses is now positive. So be very careful, again, that you're using your calculator correctly. The biggest thing to remember is that I should have all positive values because of the squared. If any one of these values is negative, I'm in trouble. All right, so wrapping up then, to find the variance, that is s squared this time. I'm going to take and sum up all of my x minus x bars squared and divide it by n minus 1 this time. And so if I sum these all up, if I sum this column, x minus x bar squared, if I sum up all of the highlighted numbers, I get 32.1. How do I know? Because I've already done this again on my calculator ahead of time. So my variance, s squared, is going to be the 32.1 divided by 9 this time. Remember, there were 10 football players, but we're going to divide by 9. And that'll give me an approximate variance of 3.57. To find the standard deviation, in this case that is just the s, it's not the sigma, lowercase sigma, it's standard deviation, and that would be the square root of 32.1 divided by 9. Now notice I'm going right back to the original one before I estimated. This is an estimate. I don't want to use the estimate. I want to use the other value that sometimes can throw you off a little bit in your My Math lab or your My Stats lab. So it's best to go back to the original problem. And I'll show you how to use your calculator on that one. So that's going to be the square root of 32, actually clear, because I think yours is going to give you an automatic parentheses there. Most people's give automatic parentheses there. This calculator does not, but most do. So that'll be 32.1 divided by 9. I want to make sure that whole thing is in parentheses. And that's going to give me 1.88856. And again, if you did the square root of 32 divided by 9 without parentheses, you're okay. What you can't do is the square root of 30, that's actually 32.1, but it doesn't matter, and then divided by 9. So if you see the difference between the first entry and the last entry, the first entry, 32.1 and the 9 are all under parentheses, all under the square root, which is what we want. In the last example, the 32.1 is the only thing under the square root. So again, be familiar with how your calculator works. You really need to practice this with your calculator. And so now that we have that value, so my S we said was approximately 1.888 something something something. So depending on where it tells you to round, that would be 1.89. Oftentimes it's going to tell you to round to the same number of digits that the variance and standard deviation are all, rounded to the same number. And that would be your standard deviation. When you're tired of doing it by hand, and again, this is just 10 entries. For both of the examples we did, there were just 10 entries. What happens whenever we have more entries? The more entries we have, the harder it's going to be to do all of this by hand. So we definitely want to use your calculator. All right. So your TI 84 or your 84 plus, 83 and 83 plus are going to work similarly to what I'm going to show you. Remember that my calculator is just a little bit different than yours in sort of the layout a little bit, but all of the buttons will be in the same location under the same menus that I'm going to describe here. All right, it's going to be much easier to do this using your calculator without having to do it by hand. All right, first thing I want to know is how many entries I have. So office space rental for Los Angeles are shown in the table. Use technology to find the mean rental rate and the sample standard deviation. This is a sample. All right, there are 1, 2, 3, 4, 5, 6, 7, 8 times 3. So there are 24 office rentals or office rates. All right. So first thing I have to do then is I'm going to hit the stat button. And then from the stat, I'm going to hit edit. And then at the edit button, I'm going to enter each data, in this case, each rate, into L1. So I don't know where your calculator was last left, but wherever your calculator was last left is where it's going to now be. So if you're borrowing a calculator, if you've done anything with statistics before in the past, if you've ever done things with lists before in the past, your calculator will be wherever it was last left. So be very cautious of that. All right, stat button. And then I have edit, calculate, and tests. Your arrow moves between them. So I want to pick number 1 for edit. And here you see what's in my calculator. That's what was last left in this calculator the last time I used it. So to clear the data, very, very careful. I'm going to go up to where L1 is highlighted, and I'm going to hit clear. Do not delete data, we clear data. I can go over to list 2. And you can see it's highlighted pink. I'm going to go up to the top of list 2, and again I'm going to clear that data. So now I have nothing in list 1 or list 2, or for that matter in list 3, 4, 5, or 6. So one more time, I'm going to hit stat, edit, Then I'm going to start entering the data into list 1. Make sure that you clear lists if needed. Clear, always clear the list. All right, so I'm going to go back to my calculator, and now I'm going to start entering that office space rental. So the first value is 51. Then I have 47, 33, 74, 24, 36, 41, 42, 30, 14, 11, 42, 40, 22, 35, 29. Okay. That is the 16th piece of data, and you can see that where it says L1 entry 16 is equal to 29. There's nothing in the 17th piece until I put in the 17th piece, which is 15, 87, 35, 51, 26, 40, 36, and 34. Remember, we said we have 24 pieces of data, and I have entered 24 items into list 1, and that last entry was 34. Do make sure that you've entered everything in correctly. You can scroll up and down to verify your numbers. Just make sure that you do have everything entered in correctly. All right, so we've entered our data. So the next thing we did, we've entered our data. All right, so this was step 1. Step 2, we're going to hit that same stat button. But instead of edit, because the data is already in there, I'm going to go over to calculate. I'm going to calculate something. What am I going to calculate? I'm going to go into the first entry, which is called 1 variable statistics. So 1 var stats. So back to my calculator. Okay, I'm going to hit the stat button. Stat button again is right there below the delete button. And you can see in the edit column, I can sort my data from ascending or descending order. I can also clear the list that way if I need to. Okay, but I'm going to go over to calculate. Number 1 is 1 variable statistics. Number 2 is 2 variable statistics. 3 is linear regression. The next one is quadratic regression. So there's a lot of options here. The one I want to pick is number 1, 1 variable statistics. I'm going to hit enter. And when I do, it's going to say, is your list in list 1? These are like questions. Is your list in list 1? And the answer is yes. Oop. Let's do it again since I hit clear instead. So stat, calculate, 1 variable statistics, and then I hit enter. And to the right, it pops out a whole bunch of information for me. Much easier than doing it by hand. Much easier. So I have X bar. That's my sample mean. I have the sum of all the x's, sum of the x's squared. That S of x is the sample standard deviation. The sigma x is this population of all that, not deviation yet, just the population. And then we have, standard, sorry, let me start over again. Okay. X bar is your average. This is the sum of all your x's, the sum of your x's squared. Neither of those buttons do we deal with. Then we have the sample standard deviation and the population standard deviation. N equals 24. That's how many data points that are in there. Then we have the max and the min, and we also have that median, that number in the middle. Okay. So if I write down what I found, again, I have X bar, which is 37.3 something something something. I'm going to average it. Then I have the sum of the x's, and the sum of the x's, really I'm not quite sure why they even put this on here. The sum of the x's was 895, and the sum of the x squared is equal to 40,171. We really never use these. So I don't know for sure why they put them on there, except that they do. And then the next thing after that is going to be your standard deviation for x, which is your sample, and that's going to be 17.18 something something something. Your population standard deviation, which is 16.82 something something something. Then we have n, which is equal to 24. It's possible then that you have this button like a down arrow key. That means you have to go down. Use your arrow key to actually go down. And then once you do that, you're also going to find some additional information. And so depending on how, whatever other information we need, in this case, nothing, because I'm not asked to find anything else. So in this case, nothing. But down below that N key is the minimum. So the next thing then would be min x, and that's your minimum value. And then there's some additional information. For what we're using right now, we are most interested in the mean, and then we're going to be interested in the standard deviation, whether it's the population or whether it is the sample. So this is the sample standard deviation. This is the population standard deviation. This is your mean. Those are the three right now that we're going to use the most. Okay, notice though, variance is not given. It does not give us variance. It gives us these two things that we don't ever use. So we don't use this and we don't use this, but neither one of those are the variance. All right. So if your question asks, which it will, ask to find the variance at times. All right. So to find the variance, remember that the variance is the square root of the standard deviation. So if it's the sample, it's the square root of the standard deviation. Yeah, I wrote this without in the correct spot. It's the square root. So to find the variance, we're going to take the standard deviation and square it. So to find the variance, we're going to take the S and we're going to square it, and this will find the sample variance. Or if I take the sigma and I square it, this would be the population variance. So we have to actually square it on our calculator. So in this case, we would have the 17.17 and square it, or the 16.82 and square it to find my variance. So 17.18 squared would be 295.1524. My 16.82 squared would be 282.9124. So you have to work backwards. In our case, what does it ask us for? So if we go back up to the beginning of the question, it asks us to find the mean rental rate and the sample standard deviation. So for our problem, this is what it asks for. This average, the mean rental rate, and it asks for the sample standard deviation. Sample standard deviation. The only way you're going to get good at this is through practicing using your calculator. I know for a lot of you, this is a lot of different buttons, so you're going to have to really practice using your calculator. And that's what this next part tells you. Use your calculator to find the office rental rates for Dallas. And this time we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we have 20 rates this time. So use your calculator and find those 20 rates. All right. So now that we know what standard deviation is, how do we interpret it? So standard deviation is a measure of the typical amount an entry deviates from the mean. So it all has to do with how it's connected to the mean. How far does things deviate from the mean? The more the entries are spread out, the greater the standard deviation. So if we look at each one of these, so my data entry versus my frequency, well, you can see these are not spread out at all. My mean is 5. And it doesn't move anywhere. So I have 0 standard deviation. Here my mean is 5 and my standard deviation is 1.2. So that's from the mean. Again, here is my mean, 1.2 from the mean. This one says that my average is 1.5, but look how much further out my standard deviation is. It's now 3 because it's further spread out. Okay. So, what we're going to use in statistics, in a lot of cases now, like I said, standard deviation is the thing we're going to focus on a lot for the rest of the chapter. And we're going to talk about the empirical rule, which is 68, 95, and 99.7. And so this says, many data sets fall within the empirical rule because the data is close to being bell-shaped. And that's what this curve is called a bell-shaped curve. Examples include IQ scores. People's IQ scores are standard, have a bell-shaped curve. When you put them all, everybody in the world on there, it'll have a bell-shaped curve. The heights, medical standards, many things are bell-shaped. That's how they know the average height of most people. That's how they know the medical, that your blood pressure should be 120/80, because that would be the average. Okay, so this is my average. That's my mean. This is 1 standard deviation to the right, so that's plus 1 standard deviation. Going this direction, that's going to be minus 1 standard deviation. So everything that falls within 1 standard deviation is about 68% of our data. Within 2 standard deviations of the mean, so again, here is my mean. I'm adding 2 standard deviations to the left and to the right. 2 standard deviations, and that's going to be this area. And that's going to cover about 95% of the population. And then within 3 standard deviations, so again, here is my mean. 3 standard deviations goes that way. So 3 standard deviations, here's my mean. Here's 3 standard deviations and 3 standard deviations. And that 3 standard deviation covers 99.7% of the population. So anything that can be put into a bell-shaped curve gives us a lot of information about how everything fits together. So if this is height, then 68% of the people are going to fall within that height. 99% of the people will fall within the red height. 99.7% of the population is going to fall in there. So where do you think your basketball players are going to fall? Basketball players quite often will fall this way. So this is going to be where your basketball players fall, often. Likewise, we can also say that back this way is probably where people who are much shorter than average people are. So that's where they will fall. So our little people fall within that category. All right. So here's an example. And we're going to talk more about height. In a survey conducted by the National Center for Health Statistics, a sample mean height of women in the United States ages 20 to 29 is 64.2 inches. So that's my mean. With a sample standard deviation of 2.9 inches. Estimate the following. All right. So if I didn't have this chart, this is what I would do. Here's my bell-shaped curve. Here's the center. The center is my average. My average is 64.2. One standard deviation is around this spot and this spot. This is one standard deviation. So I'm going to take the x bar plus my standard deviation. And this will be my x bar minus my standard deviation. So my standard deviation is 2.9 inches. So 64.2 plus 2.9 and 64.2 minus 2.9. This will get me to the right of the mean. This will get me to the left of the mean. 64.2 plus 2.9 is equal to 67.1. And 64.2 minus 2.9 is equal to 61.3. So that's this value, 67.1, 61.3. Okay. 2 standard deviations is going to be where things start flattening out. So this is my x bar minus 2 standard deviations. This would be my x bar plus 2 standard deviations. So again, I'd take 67.1 and I would add 2.9. I'd take 61.3 and I would subtract 2.9. And that's these values right here that they give us. So this would be 70.0 and 58.4. And that's right about here. And then the last one would be the blue. The blue is where it really starts cutting down. So the blue here would be x bar minus 3 standard deviations and x bar plus 3 standard deviations, which would be 55.5 and 72.9. Remembering that this is the mean. So now it's going to start to ask us about percentages. All right. This total purple area right here is 68%. That would be 34% here and 34% here. The entire red spot is going to be 95%. So 95 minus 68. 95 minus 68 is equal to 27%. And that 27% is going to fall in this red area. The 34% is in the purple area. Well, if the red area has half of its points over here and half of its points over there, if I take 27 and I divide it by 2, then I get 13.5. So this amount is going to be 13.5%. This amount is going to be 13.5%. Likewise, for the blue area, so now we're talking blue, that is 99.7% minus the 95 that we've already taken into account, and that gives me 4.7%. If I take 4.7 and I divide it by 2, so I can get some in this blue area and some in this blue area, that would be 2.35%. And this is 2.35% in this blue area and 2.35% in this blue area. Okay. Which is exactly what it shows in this chart. But like I said, the chart was figured out for us. If we didn't have the chart figured out for us, we would have to figure this out for ourselves. So my question then goes back to, in a survey conducted, the sample mean is all of this information with the standard deviation, all of it's given to us. A, find the percent of women whose heights are between 58 and 62 inches. So 58.4 and 64.2 inches. That is this area and this area. That's what it's asking, between 58.4 and 64.2. So that's the two highlighted green areas. So A would be 13.5% plus 34% for a grand total of 47.5%. So 47.5% of the population of women will be between 58.5 and 64.2 inches. And just as a frame of reference, remember that there are 12 inches in 1 foot. So 58.4 is close to, oh, these are basketball players. No, they're not. Nope, it's just sample women. So, sorry. So 58 minus 10, so roughly 58.4 inches is roughly 4 feet, 10.4 inches. All right. The B part. What percent of women have heights between 61.3 and 67.1? So that would be, find your 61.3, so that's going to be this section, all the way up to 67.1, which is this pink section. So for the B part, it's going to be 34% plus 34%, which is your 68%. So 68% of the people are going to be between 61.3 and 67.1. 5 foot is 60 inches. 5 foot is 60 inches. So this would be 5'1" to 5'7". Okay. And then the last question, C is the percent of women whose heights are less than 61.3 inches. So less than 61.3. So find 61.3, and that would be all of these people this way. All of those people. Okay. So to find those people, let's think about this for a second, what that's going to look like. So for C, all right, C is this yellow area. C is all of this yellow area. I am going to make it brown so it'll show up. So it's this area is the brown area. It says women whose height are less than this amount. Less than that amount. So to find that out then, I need to know that, a couple of ways of looking at this. Remember, this whole piece right here is 50%. So if I do 50% minus the 34 that this area is, that'll get me what's left over, and that is 16%. So 16% of the population will be shorter than 5'1". Again, this is new to most of you, so this is where your practice really has to happen. You really have to practice through this. So here's some more. Using that same chart, find these 3 examples. Okay. And then we're going to say, okay, well, what happens if my data is not bell-shaped? So if the data is not bell-shaped, then I can't use the empirical rule. Instead, I have to use what's called Chebyshev's theorem. Chebyshev's. All right, very similar, but because it's not going to be a pretty bell-shaped curve, it could be an awkward shaped curve. It says the portion of any data line within k standard deviations, we're still talking about standard deviations, is at least 1 minus k squared. So for k equal 2, so for 2 standard deviations, it's going to be 1 minus k is 2, so 1 minus k squared, that's 2 squared, which is equal to 1/4, or 3/4, sorry, it's because it's 1 minus 1/4. So about 75% is going to fall within 2 standard deviations. Remember, using the empirical rule, within 2 standard deviations, we had 95%. That's quite a difference. Within 3% for Chebyshev's, we have about 88.9% versus the empirical rule, which is 99.7. So it is quite a bit of difference. But, you know, at this point in time, there's not a whole lot we can, hope for. That's a pretty good amount. And so since it's a pretty good amount, we can't complain terribly much about it. It's better than nothing. Okay, particularly if it's not bell-shaped. All right, and now you can see some examples that are not bell-shaped. Both of these are obviously not bell-shaped curves. It says the age distribution for Georgia and Iowa is shown in the histograms. Apply Chebyshev's theorem because they're not bell-shaped to Georgia when k is equal to 2. All right, so k is equal to 2. And I'm looking at Georgia data. So for k equal to 2, all right, we know that when k is equal to 2, that means that 1 minus 1 over 2 squared, 1 minus 1/4, So that's 3/4, which is about 75% of the population is in there. We know this. This is what the formula tells us. All right. What I want to know then is where this 100 age person falls. What standard deviation is he with? So in order to do that, all right, using Georgia, we know that the mean is equal to 37.3. The standard deviation is 22.3. So we're looking at k equals 2. So we're going to take my mean, and I'm going to add 2 times the 22.3, 2 times the standard deviation, and then I'm going to take 37.3 and I'm going to subtract 2 times the 22.3. Now when I do that, in the top one, I get 81.9 years old. In the bottom one, however, I get negative 7.3. Well, that's an age, so that doesn't mean anything. So basically it means 0. So we interpret this by saying, in Georgia, about 75% of the people are between 0 and 82 years old. Right? If k is 3, which it doesn't even, well, it does right here, k is 3. All right, if k is equal to 3, remember that 3 means about 89% of the people, according to Chebyshev's rule, about 89% of the people. So I would do 37.3 plus 3 times 22.3. 37.3 minus 3 times 22.3. Well, we already know this is going to give us a negative number, which means that that translates to 0 since we're talking about ages. And then this other one, 37.3 times 3 plus 3 times 22.3, again using your calculator, gives me 104.2. 104.2. That's an old person, 104.2. So this now says, again, in Georgia, about 89% of the people are between 0 and 104 years old. All right. So now it asks you, is the age of 100 unusual for Georgia residents? Explain why. Well, that means for something to be unusual, unusual data falls outside plus or minus 2 standard deviations. Well, at 2 standard deviations, we're only at 81.9 age, 81.9 years old. So somebody who is 100 is unusual. For someone to reach 100 years old, that is unusual. Anybody who is plus or minus 2 standard deviations away from the mean. 104 is 3 standard deviations, so it's very definitely unusual. All right, and that takes us to the last try it for you. Try this one. Whoops. So you try that one. Use Iowa's data for k equals 2 and see what you can conclude. And is the age of 80 usual, unusual for Iowa residents? So this time, you're just going to see when K is 2, is 80 unusual? So find that standard deviation, see what happens, draw your conclusion, and then tell me if 80 is usual or unusual. And that wraps up 2.4. One more section in chapter.